Hey everyone, welcome back. In the previous episode we have essentially created a simulation for voting where we have our three options for which we can vote. We then calculate some percentages to basically display the winner and to output those kind of statistics. We also ran into a problem of having some excess percentage, but we took care of that as well. At the end of the episode I also explained that adding an extra option would mean that we would face a lot more duplication and this if statement would start spinning out of control. So in this episode what we're going to do is we're going to take a look at how we can abstract this solution and make this code a little bit more reusable and scalable in the long run. Let's say we want like 100 counters, we should be able to support that. So before writing any code, you might want to pause the video here and identify the duplication that we're about to remove. Otherwise, you can keep watching the video and see how I go reasoning about identifying duplication and removing it. Okay, so the first clue is looking for repetitions. And the first repetition that I see, or rather the pattern of repetition, is for every counter that we would create, we would essentially have a name for the counter and the word counter as well. So already I can say that whatever this type will be, which essentially is a counter, so I'm going to be creating a counter class with a name. We also use the counter within, basically the count of the counter, to calculate the yes percentage. So this function, since we call it 3 times math.round and we only call it on the counters, this could be a function within this class counter that I'm about to create. Another thing we do is we calculate this total, right? So every time we would add a counter, we would have to edit this line and add it on. So it's preferable that we store these counters in kind of a manager class kind of thing, which will be able to calculate this total for us. And then there's this whole Boolean logic, which is at the moment very statically typed. So we are mapping out every single condition instead of reasoning logically about who won, as well as the statistics in the end. But this can be handled by, again, this manager class, since it outputs the 3 messages for each counter. We can either output this at the counter level, but the manager will have to trigger this, or the manager can output this for every counter that it has. Okay, so at the end I'm identifying the actual counters, which will replace each one of these, and then a counter manager class, which will essentially help me derive the total, handle the excess, and find the actual winner. So let's go ahead and create this counter class, right? What I'm going to do is at the top here, I'll create a public class counter. As I've said before, it should have a name. So let's go ahead and give it a property of string name. And what I'm going to do is I'm going to create a constructor where I will pass in the name and the count. Okay, so I'm going to start with a count, which is essentially the only thing that I'm doing in my declaration. So I have the name, I have kind of the class name, and I have the count that I have, right? So I'm going to pass in the name in the constructor and the count as well. And what I want to do is to the name, I want to assign the name. And the thing is, I don't want this name to change, so I'm going to remove the setter from the property. And if you're wondering what the property is, it's basically the convention that came from Java, another object-oriented programming language of which the C# is a copy of. Essentially, the pattern to write classes would be private string name, okay, and we would have a private variable, and you wouldn't want to change it through just accessing this field directly. What you want to do is you want to explicitly say you want to get the name like this, or you want to void set the name like this. Okay, so this was the pattern for how things were getting done in Java, and since C# was a copy, they essentially copied that, and that was essentially the same thing that was happening. So what the property does is it gives you the getter and the setter, so it will have these get name and the set name in the background of this one, and you can actually implement these functions within this property here. Alright, but what this property does is essentially would be the equivalent of not having the set name, since I have removed the setter, so there is no way to actually set the name. Okay, so let's remove that. We only have the private field and the getter for that field as well. Okay, and let's go ahead and create a counter. And I think I'd prefer to actually for it to be count the same. I just want a getter on this one, so I don't want anybody editing this count by more than 1, which is essentially every time you vote you're gonna increment this counter. Okay, so what I'm gonna do is the count as well, I'm just gonna set it from the constructor as well, and I just said that I would like to increment the counter, but I'm not gonna implement this function because nowhere in here that we're doing this, and adding on this unneeded functionality at the moment is not needed. We're not using it. Okay, so let's go ahead and replace these counters with the counter class. Okay, so slowly I'll create a variable and I'll just call it yes, since when I say equals new counter, and I'm gonna give it a name of yes, and what was the number, I mean, it doesn't really matter. It's apparent that it's a counter, and when we hover over it, it will say counter yes. So we don't really need to say yes counter. We can just rely on yes, because at the moment the context is small and we can understand it that it's a counter. So let's go ahead and do the same for no and maybe. Nope. And maybe. Say nope. Maybe. And now what I'm going to do, I'm just going to go ahead and remove these counters, see where it errors, and see how I can handle this. So first of all, the total breaks. So what I want to do is I want to just, instead of grabbing the yes counter, I want to grab yes and navigate to the count property instead of grabbing these counters. And I want to do that essentially for everywhere where I check the counter. Okay, so what I'm going to do is I'm going to use Visual Studio's refactoring to help me do this. So for the yes counter, I'm going to press Ctrl H, right? And this is going to pop this window up here. And now in here, I can just type in yes.counter, or instead of counter, count, yes.count. And this is going to replace every occurrence of yes counter with yes count. So for example, I replace this one and the error goes away because this property exists within this class, unlike the no counter and the maybe counter, which just plainly do not exist. And I'm going to press this button, replace all, or I can press Alt A and it's going to replace all occurrences. Okay, and 7 occurrences replaced, and everywhere where there was the yes counter, there is now yes.count. I'm going to do the same for the no counter and the maybe counter. So pressing Ctrl H is going to put it on top here, and now here I can just replace the no, yes with the no, replace it everywhere, make sure I don't get errors. I don't. Now I select the maybe counter, replace the no with the maybe, press Ctrl A, and there we go. So at the moment have no errors. I am gonna put these to 2 and 3, and maybe I'll put this to 4 since I want to see what happens with that draw and incrementation of the percent on the maybe. Yeah, and here we can see the draw. It would also be nice to see between who the draw is also happening. So it's a draw, but like between who. So let's go ahead and do that now real quickly. So this draw is between yes and maybe, actually. This draw is between no and maybe. And this draw is between no and yes, actually, because maybe would be lower, but if it's equal, then the draw is between all of them. So let's actually implement. This is a condition that we have lost. So if it equals, then the draw is between all 3 of them. Okay. So let's test that. And the maybe percent, I don't want to put it on here. I will put it on the maybe excess here. because the draw is then between just no and yes. Okay, so let's see it. Okay, so I can see the excess is being added onto the maybe count, and if I increment this to 4, should increase it. All of them should go to 333, and total percentage is not increment, and it's a draw between all three. Okay, I'm happy with that. Sorry, small deviation. Let's carry on. So the next step would be this function right here, right? So you can see that we are essentially using the total and the yes count, right? So there's only two variables. The yes count is within our counter, and what we will need to do if we want to stop repeating this sort of pattern of calling math.round, we need to put this function in here, right? So the repetition really is calling math.round here, right? So we're calling it 3 times. We only need to call it once, okay? And the way we do this, let's go ahead and grab this right here. I'll copy it. I will not delete it for now. What we're doing here is we're getting percentage. So what we can do is we can say public double, since that's what it returns. If you hover over yes %, you're going to see that it's a type of double. So public double, you can say get %, and now we can return whatever we copied. Now yes doesn't exist in this context, so what we're going to do is we're going to remove the yes and rather target this count. Now the total comes from the outside, and as I mentioned before, I would like it to come from this manager object. So this is what I'm going to do. I'm just going to pass the total in this function here. I can get the percentage just by calling get % and passing the total on the counter that I want to get the percentage from. Okay, so let's try this. Let's say yes dot get %, and let's say pass the total, and let's do the same for all of them. So no dot get % total, maybe dot get % total. Okay, and I have a feeling because we're doing the same sort of thing here, or are we? No, we're rounding up the yes %. We'll get to that later. It's just me getting distracted slightly. So let's go ahead and run the sandbox. So we still get the same result, which is nice. So now that we're sort of at a place where the logic that we have is sort of a step-by-step logic, rather than how I think a bit of it is like aggregated logic, and hopefully it will make sense once we implement the manager. But this right here is sort of a repetition kind of thing, because these things, because they're of the same type, they could be in a list, and because we have LINQ, the operations on LINQ provide very readable code. So let's go ahead and create this counter, which will be initiated with a list of counters, or maybe a parameter of counters. So let's go ahead and create a public class counter manager. And what I want to have here is something to do this total, and for that I will need to store every single counter, and for that I'm going to use a list. So let's go ahead and create a property, and I will create a list of counter. I will need to import system.collections.generic, and I am going to name this counters. Okay, and what I'm going to do in my constructor, I have a couple of ways that I want to initiate this. Let me close this error. The first one would be flat out passing a list of counter. Let's call this counters small. Counters equals counters, and doing it this way. So now let's create the manager. Okay, what we can pass in here is a new list of counters with initial variables of yes, no, and maybe, and this will create a list with these counters, and then these counters will be assigned to this property. Okay, another way you could pass these parameters to this counter manager is using the params keyword, and it can be preferable sometimes. I sometimes like it. So if we say params counter array, and we'll say that it's counters, we'll get an error here which will essentially say cannot implicitly convert counter array to a list of counters, which we can then basically say actually, let's not handle this. Let's first see the benefit that we get when initializing. What we'll get is basically we no longer have to initialize a list here. We can just pass the counters that we want to this counter manager. And what we can do here is essentially just initialize a list from this array here. So let's say new list of type counter, and in the constructor let's go ahead and pass this array of counters. So even if it's empty, we're gonna end up with at least an object assigned to this counters property. Otherwise, if we don't have this, if we don't populate the counters with anything, we'll just get a new null reference exception. Whichever one you prefer, both of them are pretty readable. This one makes the constructor a little bit cleaner. The previous one will have or I guess that's the other way around. This one makes the constructor just a tad messier. This makes the declaration or the initialization of the class a little bit cleaner. So whichever one you prefer. Alright, so enough rambling. Let's get to the total, right? So what we can do here is let's go ahead and make public int total. And since we have access to all the counters that we do here, what we can do is something along the lines of int total equals 0, and then a for each loop var c, which will stand for counter, and then we'll grab for every counter. We're going to add to the total the count of every counter, right? So at the end we'll end up with the total, and then we will return the total from here. Okay, so you can see that there's a solution here. It's not as neat as it could be. Using LINQ, it can be a lot neater, but essentially the problem here is the side effect of this local state, which is in this form of total. This isn't necessarily too bad. This just makes this super verbose, and there's something that we can use that can make this a little bit easier. If you're not familiar with LINQ, leave a comment. If you would like a tutorial on it, I would love to teach it. I just feel like it's something that everybody already knows. If you don't know it, leave a comment, or if there's already a comment, like it, comment on it, let me know that you guys want a LINQ tutorial. But yeah, what we can do here is essentially retrieve the total from the counters using LINQ. So let's go ahead and do this, right? I'm rambling on too much. Let's go ahead and after we grab the counters, because it's a list, LINQ is an abstraction of extension classes that perform common operations. So we will say sum and then alt enter, and we will get an option to using system.linq, and this will put a statement on top here. And now we're gonna sum here. So if we just F12 on sum, we will see that this IEnumerable of t source, and all this means is something that implements IEnumerable of t source, which is type source, and list implements IEnumerable of type t, which is essentially, if we go there, t will be the source, which is the same type here of which the list is. In our case, it's a counter, right? So this is essentially how you write an extension method, and this will be the source. This will be our counter collection. And the next thing is a function that we are going to pass in order to determine the sum. For basically, you can see most of these are number types, so decimal, double, float, long, int, and yeah, all of them. We're basically going to select a property for which to sum it up. So let's go ahead and pass an x, and this will be a function. All right, so it's going to take our counter object and it's going to stick it in here, and this is the same as having a function just written out here, and I'm just going to show it in a second. So let's go ahead and just select the property here, and we'll just do x.count, right? So what is this equal to? This will essentially equal to public int, since the counter is an integer, and we will essentially do something like selector, because this is a test thing. I'm not actually, I'm going to remove this in a second, but this is just to allow you to understand what this function is. And all we're going to do is pass a counter into here, and then we're going to return counter.count. Okay, this is all this function does, right? Except it's a lambda function. It's an anonymous function. Lambda functions are anonymous functions, which means they don't have a name, right? This one has a name, and what we can do, we can just pass the selector here without calling it with the brackets, right? So we are passing in a function as a parameter. This is part of the functional programming paradigms. However, the preferred way is writing a lambda function, because this is a specific scenario and there is no reusability in using this function. So I'm going to remove it, right? But just for your information, this is what the lambda function would look like if it was a named function within a class. Okay, and now this function will essentially return a sum of all these counters, and all we can do is just return it, and then the rest of this isn't needed. Okay, and usually when something's a single line statement or expression, I would like to convert it to a lambda expression. All right, so just a single statement. So this is an expression because it returns a value. A statement doesn't return a value. So for example, if we would implement the increment statement here, since that doesn't return anything, it just increments a value in memory, that would be a statement. Okay, so you could still do that. So just for example, let's do public void, right? Statement is void. Let's say increment, and again, this is just a function, and we're gonna go to the count and we're gonna add it up, right? And okay, because I removed the setter, even the class that I've created here can't access it. So what I can do is I can add a private set. So within the class, I can access it or set it. With outside of this class, I can't set it. Okay, but this is example of a lambda expression with a statement in the body of it. Okay, so I'm happy with that. I'm getting the total. Let's go ahead and use this manager to grab this total, right? So we're going to remove this line here. And for everywhere where we have the total, you can see I'm going to use the same thing I used yesterday, previously, to replace stuff, except this time you can see it's highlighting this total here. What I can do is I can look down anywhere else where it's using it. It's only using it here, so let's go ahead and highlight this bit and drop down to selection. And what I'm going to do is I'm going to type in manager total and call the function, and then Alt A, and it's only going to replace it here, and it's going to leave the rest of them alone. So I have the manager, I have the counters that go inside the manager. What are the next step to optimizing it? Well, really I have to ask myself, why am I creating these yes percents? And the answer will be, if I remember, is to show these statistics at the bottom here. And also part of this whole gimmick is this excess thing here, which at the moment we won't be able to actually add it onto anywhere, because we're always sort of deriving it. And I'll show you how to handle that in a second. But what I want to do now is essentially all this stuff that I'm doing here, I want to just go ahead and move it into the manager class, right? So all of this malarkey, I want to move it into the manager class. So let's go ahead and do that. What I'm going to do is just say announce winner, or like show statistics or something like that, right? So public announce winner. You can call it show statistics, whatever it is, right? So let's go ahead, select all of this right after we declared the manager and pop it into here. Alt-Shift-A to format it. Didn't do much for me there because it was just my screen going to the right, but yeah, let's grab the manager and let's announce winner. It looks good to me. Let me actually drop down my solution for more screen space. And here I'm going to scroll up to the top And the first thing that I notice is that actually I'm doing all this passing of basically of manager total. I'm passing it 3 times, and all of this is to get these yes percents, to basically sum them up first and subtract from 100 to get the excess. So essentially what I want to do is retrieve a sum of all percentages, right? So let's go ahead and copy this total, and let's say total percentage. And here all that I want to do is essentially, because this is a counter, I'm going to call get percent, and I'm going to pass the total function here. And one thing is this is going to return a double, and this is an integer here, so let's go ahead and change this to double. So total percentage is now a double, and what this allows us to do is essentially get rid of all these 3 statements here, because all we're going to do is grab this total percentage function here and pop it like this. Okay, so for now I want to ignore this excess for just a minute, because we are doing we're calculating the excess based on the winner, and I want to just avoid that for a second. This is a big tree of if statements, like cyclomatic complexities of the charts, whatever. I want to come over here, and I want to basically, what I've implemented here, I want to do the same thing there, right? So every time I'm going to get the total percentage here, I'm just going to go ahead and call total percentage here as well, and it's going to round it up. Next thing is displaying the winners, and again, it's the same sort of thing. We have the name, we have the counter, so what we can do is for each, let's just say C in counters, so C will stand for counter, surprise. And let's copy this one statement here, and let's say instead of yes, we're going to put the brackets. I'll just say display the name, and then C display the count, and then this math random, let's do C dot get percent, and again we can pass the total here. Okay, so we can remove these 3 console write lines for each individual ones of them. Now it's just a matter of how many counters we have. We are going to calculate this for every single one of them. Okay, now for this big if statement, right? The reasoning behind this is, before I've said that essentially we are mapping out every single condition that is possible. So every single condition that could happen, we're mapping it out for every single counter that we registered. This isn't generic, this is a very concrete implementation, okay? And this is not using any logic, this is just brute forcing, okay? So rather than looking for every single counter that we have and then mapping out every possible branch that a computer can go and make, let's think about this differently. Let's go ahead and just remove the whole thing, because that way of thinking no longer applies here. What we have is a completely different solution where we have an arbitrary amount of counters, right? So any amount of counters. So how do we know that there is a winner? This is probably a moment where you want to pause the video if you got up to this long and just have a think about it, right? If not, you can watch the way I do. So we have some amount of counters. How would I reason about selecting a winner? Well, whoever has the most votes wins, right? So let's go ahead and do that, right? So let's first get the biggest amount of votes, right? So let's just do that. Biggest amount of votes equals, and again we're going to go to the counters object, and there is a max function which is going to select the maximum value in this collection. And again, this is going to be a counter type, and x dot count is the property that I want to supply. Okay, and let's go ahead and put a semicolon there. So we have the biggest amount of votes, and this is an integer. This doesn't tell us about which counter it is, okay? So this is the biggest amount of votes anyone can have, right? So let's go ahead and grab every single counter, right? Because as we've seen before, there can be more than one counter with the biggest amount of votes, right? When you get 3 draws, when you get 2 draws, there is multiple conditions, right? So let's go and say, let's grab the winners, because if this is the biggest one, we have a couple of winners. So let's grab the winners, and we're going to go to the counters, and we are going to say where, and where is something like a filter kind of function, right? We're going to grab a collection and we're going to filter it by a condition. And again, the condition here is going to take our counter object, and we're going to say where the count equals biggest amount of votes, all right? And we're going to get an IEnumerable of counters, and if we cast it to a list, this will just mean that we are not going to regenerate this list every time we call something on the winners. And if you want a tutorial on IEnumerables and list and their applications, also leave a comment. Otherwise, let's carry on. So we have all the winners, right? And here is where our sort of if statements come, right? If there is one winner, there's a winner, right? So let's go ahead and do that. If winners equals 1, let's go ahead and grab this winner by doing first. If you don't want to do first, you can just use the array if that's preferable. I find this a little bit more readable since we're already using a bit of LINQ here. This kind of melds in a little bit better in my perspective. So we'll grab the winner and we will just say console right line, and as we did before, string interpolation, winner name 1. Okay, so now we are basically depending on an arbitrary amount of, it doesn't matter how many counters we have, as long as someone has, as long as it's just one counter that has the biggest amount of votes, that just means he's the winner, right? And because we are tracking the name in the counter now, we can essentially know who won. All right, here's for the else statements, right? So the next 3 conditions are, or sorry, not the 3, next 2 conditions, because if you remember the difference between the draw between all of them, all of the counters, and the draw between some of the counters is essentially us doing something with the excess, right? So if everyone's drawing, we're not adding on the excess. If some of the counters draw when they're winning, we add the excess to one of the losers. So what I want to do is actually map out the condition for all draws, because it seems simpler, and it will go something like if winners.count equals counters.count. This means all of them draw, and what I'm going to do is I'm just going to say string join, and just the thing that I had before, and actually I prefer these smaller case ones. And the first thing is I'm going to pass a string which I want all other strings to connect with, and then I'm going to pass in the winners.select, and I'm just going to select the property which is going to be name. And then otherwise I want to add the access. There is no need to write the code straight away. You can just put a comment for where you need, as long as you understand what the logic is. This is where we want to add the access, and we want to add the access onto the winner here as well before displaying it here. Okay, so adding on a comment is fine. Next thing, we actually want to do the same thing here. So this is actually a bit of duplication. So we have 2 rows that are actually doing exactly the same. So what I'm going to do is I'm going to grab this if statement. I'm going to put it inside here and remove this else here. So what will happen is if we have one winner, just go ahead and say he's the winner. Otherwise, add the excess on only if the winner count doesn't equals the counter count, right? Otherwise, we always want to display the draws this way, by joined by a draw, no matter how many there are. Okay, so let's do something about this excess. So the first thing that we wanted to do, so we actually have it here. What we want to do here is add the excess onto the lowest percentage, and what we want to do here is just add the excess onto the winner. Let's see how we can actually go ahead and add the excess. Because if we take a look at our counter, whenever we get the percentage, it's always derived, okay? So we're not actually storing the percentage anywhere, and we can actually start doing that. So let's go ahead and create a private field for the percentage. Private double for percentage, and we're gonna say underscore percentage. I'll just put a semicolon, and private fields usually go above the constructor. You can also make it read-only. Another thing that I want to do is I want to make it a nullable. So when this class gets created, if it's not a nullable, it's going to equal to 0.0. If it is a nullable, it's going to equal to null instead of a 0. Okay, so what this will allow me to do is, if I want to get the percentage, I want to go ahead and return the percentage unless it's null. Then what I want to do is I want to grab the percentage and I want to return the percentage after the percentage has been added on. So the very first time this is going to be null, and this percentage is going to be stored in the percentage, and then this is essentially a cached percentage for this counter, and this will allow me then to have a function that can add the excess to this percentage after it's been derived the first time. So let's go ahead and see what this error is about. Okay, so it seems like it's just confused in which order this is executed. So let's go ahead and put the parentheses around the right hand side of this statement. And now we're going to get a read-only field cannot be assigned to. So let's go ahead and actually remove the read-only part, since we do want to assign to it. And the next error is cannot implicitly convert to type double from essentially double nullable. So what we actually want to do here is grab the value. Since logically thinking about it is, if percentage is null, we're gonna go here, right? So this will inherently only return the value if it's not null. So this will essentially equal to a double in the end. After basically questioning it, if it's null, now going to this side, essentially C# is not sure if this is going to be a null or not. So what I'm going to do is the wrapped part in parentheses, I'm just going to grab the value of. And this is how I'm going to grab the percentage essentially, right? So this is a common practice to essentially cache a result of return value, okay? So it can be constantly derived. However, if you need to store the value, this can be a way that you can do it, right? So we have the percentage. Let's go ahead and public void add excess, and we're gonna have double excess. And again, what we can do is we can, because it's void and you see me do the increment lambda statement, we can do the same thing here, but let's first do it the normal way. Percentage plus excess, or rather, sorry, plus equals excess, because we're adding it on, right? So this is the statement. We can change it to a lambda expression, and I usually tend to do these if these are one-liners, and we can do the same with this thing here. If it makes you more comfortable, you can drop it to a new line. I am okay with it being here, and even more so because sometimes my screen is slightly bigger than 140% zoomed in. I'll put it on what's it called, on the same line there. But yeah, or less, let me drop it down for those of you who are copying from the screen. So we're gonna either get the percentage. If it's null, we're gonna derive a percentage. This obviously comes with its caveats. If the count changes, then the percentage will not be derived again, right? Because it's cached, and this is a common problem with caching. But nevertheless, let's get going, because for this application this is perfect. This is how we want to add on the excess. So let's go ahead onto our counter manager, and let's grab the excess here, and let's just take the winner and add the excess. And if it's 0, 0, it's not going to add anything, so we don't have to worry about that condition. If it's anything more than 0.01, it doesn't help us to check an if statement, right? Because if it's 0, 0, it's gonna be good either way. All right. So this one's a little bit more trickier, because we're searching for a loser, which we have somewhere back in the counter here. So let's go ahead and do something similar here. Let's say lowest amount of votes, right? So we're looking for a loser, and the max, we're gonna replace it with a min. Okay. And now what I want to do is I want to actually just grab first, right? So there's going to be somebody with this amount. So we're just going to grab the first person with the lowest amount of votes, and we're going to call him loser. Okay. And for this loser, there he is. We're just going to go ahead and add the excess here. Okay. So this looks all right to me. Let's go ahead and run our application. So the percentage bits look fine. The total percentage looks fine as well to me. One thing is we're not getting the winner or the draw. So let's see what's happening. We just didn't hit this condition, and we're not actually console writing this. So let's actually console write it. So console write line. Like so. And let's run this and make sure we get the draw. Alright, so we can see that the draw we're getting are between all three of them. Let's push one down. So if we go back here and put 1, 2, 3, or maybe 2, 3, there should be a draw between a yes and a no. We can see the excess is of 0.01, and that should be added on to the maybe counter, but it looks like it's actually been added on to the yes counts. So let's go ahead and check it out. I think I just botched up the first selection here. So yeah, I'm still using the biggest amount. So no wonder it added grabbed the first one with the biggest count. So let's go ahead and grab the lowest amount, put it here. Let's run this. And now we can see that it's actually added onto the maybe counter, and the percentage for the other two remains the same. Okay. And we can see the draw is only between two pieces, so, or rather counters. So let's go ahead and see a winner. So 4, 2, and 3. And here we can see that yes has won. We can see the percentage being added on here. I'd say all looks good, but however we do get this same error as we did before. I am not too much concerned about it at this point. I'm happy with it the way it is. Another thing that I would actually like to do is just go ahead and add another counter. And let's say something like hopefully. All right. So we're offloading onto someone else. Okay. Yeah, and let's just say that all of them are gonna win. Yeah, no excess, everyone drawed. Without actual addition of any additional code to these ones, we can just go ahead, add another counter, add it to the manager, and the manager will take care of deciding a winner, announcing the winner, etc. So in conclusion, what we've essentially done, we abstracted the counter and the counter manager, somebody who's going to manage all these counters. And we have implemented convenient functions, right? So this is what's called sort of abstracting or thinking in abstractions, right? Somebody who has a lot of experience programming, when they're gonna create websites that are gonna be like a voting website, they're gonna know to create these counters or vote objects straight away. This is not something that you might think of straight away. Maybe you have. but still decided to watch these tutorials. Thank you for that. So hopefully for the previous and this episode has shown you a progression of how you can sort of like, right, I don't know anything about building it, starting it with the simplest conditions, and then once you sort of see yourself struggle with implementing or scaling it to like, because you start with 2 and then you're gonna want to go up to 3 or 4 or 5, and that's when you see your if statements kind of like choking you or being a choke point for you, and this is where you gotta stop and you gotta think about the solution a little bit differently. And this is where we sort of reach the choke point. We spot it early, and we identify the duplication that we currently have, and we identify the objects to which we can sort of off-put this logic into. Okay, and this is essentially the development process that you will get to skip. You will get to sort of reach this straight away once you have the experience, because once you sort of think like a programmer more and more every day, you think in terms of higher abstractions rather than your integers, strings, and booleans, etc. You start thinking in actual objects that you can assemble. Hopefully this gives you a good idea. Thanks for watching. This will be it for this episode. If you enjoyed this episode, leave a like, subscribe. If you have any questions, make sure to leave them in the comment section. Don't forget to join the Discord server. Go check out my writer series. You can go ahead and grab the extension code for the writer IDE. And as always, I'll see you in my other episodes.